Well, hello guys. I'm going to take a real short break from the Scott 800B to give do a quick little bench test and give an estimate to a guy on this Zenith portable radio. This is an AM broadcast radio, AC DC. In other words, it will operate off of 117 volts line voltage from the wall, or it uses an AB battery set. It's a 6-tube radio. It's got 117 volt rectifier, a 3 volt tube and some 1 volt tubes. So it's got some unusual tubes in it, ones that I don't work with every day. I'm familiar enough with them, but I don't work with them every day, and I really don't have it memorized which tube serves which purpose in the radio like I have with the 6 and 12 volt stuff. We're going to give this one a look. I've already done a couple things. I basically have plugged it in to the Variac, and I've got my signal generator going. It's well, I haven't got the frequency counter hooked up, but I'm putting out 455 kilohertz, and I'm coupling it just through a small wire loop antenna into the wave magnet. With these Zeniths, that's usually more than sufficient to put a 455 kilocycle signal into the radio and tell if the IFs are working and so forth. There's no problem with accidentally putting line voltage into the battery side of this, because just like many battery operated radios right here, in order to operate it as a battery radio, you are supposed to plug the electrical cord into this little device right here, and it takes the AC, the 117 volt AC side of the circuit out of the picture. It does have a field coil speaker. It's actually a rather conservative chassis. It's much like other chassis. It is a transformerless radio, hence the 117 volt rectifier tube, which is this guy. Let's see, where's my finger? Right there. There's the rectifier tube. That much I do know. That's a 3 volt tube there, and the rest are one LA something, one LH. I just haven't memorized the 1 volt tubes. I've repaired radios with them before, but I really haven't had to do any serious research on these tubes. So I might have to on this radio. Who knows? So let me pause here for a second, get set up, and we'll turn it on. Variac is plugged in. Let's turn on the isolation transformer. All right, I need a pilot lamp on this side. All right, turn on the Variac. Right now I'm at 0 volts. 0 volts and no current. Okay. Switch on the radio is on. All right, I'm going to go ahead and turn up the voltage slowly. Put it at about 45 volts first. See if I get anything. I don't expect to see anything. What I'm watching is current. As I turn this up, if that current goes up rapidly or suddenly, and I know I have a problem inside the radio, and I'll shut it down. So let me go up a little more, 60 volts. So far, current has not moved at all, which is a sign that I'm not doing much. 117 volts. Let me look here. Okay, the rectifier tube is lit, so that's good. Looking at the schemo, and it makes sense with a 117 volt rectifier tube that these actually would be in parallel. So this is not a string series filament circuit like in an All-American 5. So that means that it is possible for one tube to be live and another tube to have an open filament or some such, so that you wouldn't have current flowing through that tube. Now, I have a really faint hum in the speaker. Okay, so that tells me the audio circuit, at least the audio transformer is okay. I can, I know that the power supply is at least functional. I may have a dead tube, may have other things. Let me crank up the output all the way on my signal generator. Okay, 454.92. I'm not going to get much closer than that. Okay, so output is up very high on the signal generator, and I got nothing. And normally, even if I've got something that's weak with that much output to the antenna, I would get something. first I'll test the tubes. Here's how it's going to proceed. I'm going to take it apart. I've already removed the screws for the chassis, and then I remembered I needed to make a video. So I'll remove the chassis. I'll make sure that I can still connect the speaker. And then I will power it up again, and I'll look in the dark for filaments. Then I get nothing, and I'll start testing tubes. Once I'm convinced that all the tubes are good, then I'll start other troubleshooting. But I also want to get a look underneath it. But since I'm hearing hum, I know that the output transformer is very likely to be fine. The power supply seems to be working. I've got a rectifier working. Speaker field coil is working. And the speaker voice coil is working. Otherwise, I wouldn't have the hum I'm hearing, because it's a pretty standard 60 hertz hum. So I'm going to go ahead and look underneath it, see what I'm going to have to deal with. I want to have this wrapped up tonight so I can send the guy an email tomorrow on what it would cost to restore just the electronics of this radio. I'd love to find out who can do the Tolex on these, because I'm not even sure, this isn't really Tolex. But who can recover the exterior of these? Because these are really cool radios, and I own one very similar, and I'd like to be able to recover it as well. All right, so let's proceed. I'll get the chassis out, and then we'll start back up. The chassis is out. Before the rectifier tube's still hot. It kind of gave me a start. Before I go powering this up again, let's take a really fast look underneath it. It's really an easy chassis to handle. All right, so it looks like all the original caps are there. And guess what, guys? Guess when this radio was made? How much you want to bet? How much you want to guess? Let's see. I would bet this radio was made. I don't know for sure. Let's look at the model number. I bet you can't guess. All right, so the radio model number is 6G501M, as in Mary. Okay, 6G, that tells us 6-tube portable radio. 501, the 5 tells us this radio was built in 1941. Well, guess what we all know about 1938 to about 42 radios? Every dang one of these wires is likely to be degraded in some way, or a lot of them. See, there's one right there. Crumbles. I don't know if you can see it, just crumbles, okay? Bad juju. Some of these wires are okay. Some of them can be saved. Some of them can be left alone. This is a really tight chassis, but some of them can be left alone. A lot of them have to be replaced. So bingo, there's the first hit right now. A lot of those wires have to be replaced. So I know the power switch is fine because I turned it on and off and I listened to the hum come on and go off. All right, so I know that's okay. There is no band switch. It's an AM only radio, so that takes a lot of the complication out of the picture. So what we have now, we're going to take this radio and we're going to put it here with the chassis. Okay. I'm sorry, put it here with the cabinet. And then I'm going to try and connect this speaker up here. It's a really short cable, so let's see how I can do it without causing any problems. I want to take real good care of this cabinet because the cabinet's actually in pretty decent shape, and I want to keep it that way. So let's set that up there. Cable's really short on this speaker. I don't want to have to disconnect the speaker. That would be a lot of pain in the butt for nothing. Okay, so that is connected. You know what? I know what I'll do. And I have them right here. Don't even have to pause. I'll tell you, man. Just like the Boy Scouts say, be prepared. Be prepared. All right, so I'm going to set this radio up on some wood. All right. Yikes. That was kind of boneheaded. There we go. That's what I meant to do right there. Set it on some wood. Now I think I can make this work. You know, there's a lot beats the hell out of a Philco radio where you have to desolder the dang speaker before you can pull the chassis out. All right, there you go. Speaker is hooked up because that's part of the power supply. So that field coil that's in that speaker is part of the power supply. So that has to be in circuit for this thing to be operating. I quickly damage an output transformer or other parts if I don't do that. So it is on. Okay, so now what I'm going to do is I'm going to put it back up to 117 volts. Now, remembering that although this is not an All-American 5, it is an AC/DC radio, and there's a very good chance that I could get myself shocked nasty by touching that chassis or parts that are touching the chassis. So what am I going to do? I'm going to take these knobs, these plastic knobs that are part of the radio. I'm going to go ahead and install these knobs just in case, because I'm cautious and I don't want to hurt myself. Wouldn't it be? It'd probably make for great video to see me fall over twitching, electrocuting myself on the ground. But, you know, who'd get up and turn the camera off and it was all done? So here we go. Okay. Radio's on, turned all the way up. Let me turn off some lights. So it's going to kind of change the look of the video a little bit, but I want to see if we can see some filaments. All right, let's bump some voltage up, shall we? I'll use my flashlight to see the variac while we do that. Okay, I've got it at 117 volts, as you can see, because that rectifier is glowing, but that is the only tube that is glowing. I don't see a thing coming from that converter tube. I'm sorry, from the power tube, power output tube. I don't see a thing coming from the converter tube. From the IF tube, I got nothing. So all of those are in parallel. Hold on a second. I may have something here. Is that a reflection? No, sir. Oh, it's a reflection off of my stupid variac. I need to change the color of the pilot lamp on my variac, because that thing reflects and makes it look like tube glow. If I made that green, I'd be able to tell that wasn't tube glow when I glanced at it. So I'm not seeing a thing, man. All right, so it is utterly dark in the room. The only thing glowing, sorry for the really boring picture here, the only thing glowing is this rectifier tube right here. So, all right, so we know that now. We know that that thing is, it's got either some dead tubes or some problems with the filament circuit. Check this out, guys. I never really paid attention to my signal generator in the dark before. That's pretty cool. Look at that. That's neat, man. I like that. That's cool. I never really looked at it in the dark. I knew it had a lamp, but I never saw it in the dark before. Pretty cool. All right, let me pause this and we'll get to looking at what's going on with this radio. All right, I have the tube tester warming up. This is not a fancy tube tester. This is an old Warhorse. It was given to me by a good friend who was in the radio business for many, many years. And he put many hours, thousands of tests on this tube tester. He's recapped it a couple of times, and it looks well worn, but I'm telling you, it's a pretty good and pretty reliable tube tester. It's not let me down yet. So I looked up, the first tube is this power amplifier tube and power output tube. And this thing is a 3Q5, if I remember the number scheme correctly. Yep, 3Q5. Okay, it is an octal tube, so I'm going to set this thing up for a 3Q5, and then I'll stick this in the octal hole. All right, so I have it dialed up here on the tube chart. 3Q5, the filament voltage, or the filament is 1.4. 1.4. The grid voltage, 25 volts. Right? 25. Terrific. Plate voltage is 27. Bring this down to 27. Okay. Very good. And set up all these various parameters. Let's see, it's 1, 2, 4, 3, 1, 2, 4, 3, 5, 1, 2, 5, 1, 2. Second set are all ones all the way across. V and S are 2 and 3, 2 and 3, and there we go. So it should be ready. I check my line voltage, make sure I'm okay there. There we go. Okay, I've got all my parameters set up. Go ahead and put the tube in it now. I do see a faint glow. Very, very cool. That's all right. Good. Filament I know is good in this. I know you can check for shorts and all that, but I see a faint glow, so that's good. So it says to check merit. In other words, to check if the tube is good, press button number 3. I've done that. Let's just see what it says. Oh my, it says that's a really strong tube. Make sure I have everything set up right. 1, 2, 4, 3, 1, 2, 4, 3, 5, 1, 2, 5, 1, 2. Ones all the way across. I'm missing a knob here. If you ever see one of these, let me know. Merit again was 3. Just one more time. It says it's a really strong tube. Okay, so you know what? That glow is so faint that it's no wonder I didn't see it on the camera. Get reset. Pluck this tube out. Okay, so I believe this tube to be good. All right, so this tube is a 1LH4. Let me see. That's an old tube, so that's interesting. It's a Lochel tube. By the way, I happen to have a bunch of these, so that's good. They're not easy to find, but I stumbled on some not too long ago. Okay, I dug out the supplement chart, and it looks like for the 1LN5, 1.4 filament voltage, of course. Grid voltage is 7, just like before. The plate voltage is 65, so I had too high a plate voltage on there. I hope that's not a problem. So plate voltage is 65. All right, 231. So 231. Oops. Okay, 2331. 2331. 6, 5, 1, 2. All right, 1LN5. 2331651. 2331651. Okay. It's ones all the way across. 4 and 4. Okay. And the merit is 2. Okay, 2. So let's give this a shot, shall we? Let's go ahead and stick the 1LN5 into the socket. See if we get anything. All right. Let it warm up in case there's a good filament in it. Oh boy, that just pegged good. Wow. You guys see that? That pegged good. Holy moly. Let me make sure I got everything set up right, because when it pegs that strong, it makes me wonder. Well, I can't see a filament, but there's between the getter and all of the shielding inside the tube, or the elements inside the tube. I sure can't see it, so I'm not surprised by the way this tube is constructed. I'm just going to have to trust the tube tester. Okay, that looks good, so we'll pluck that tube out. How about a 1LH4? 1LH4, I saw that in this same chart. Put the tube in, let it warm up for a second. These 1-volt tubes warm up really fast, so it's not like you have to let them sit all day. It shows good. Okay. There we go. Gotta warm up for a second. Says good. Make sure I'm checking if got it set up right. Whoa. Well, isn't that very strange? You know what? That's weird. I think that thing had a filament go open. It had started moving up to good, and then it just suddenly dropped back down. Now it won't do anything. It's either intermittently bad or the filament was about to quit and finally went open when I tested it. Okay. Well, you pause this. I'll go find another 1LN5. I have them around. Okay, so I just put a brand new 1LN5 in there. This is new old stock, right out of my new old stock stash of Lochtel tubes. Very strong, very, very strong. So let's check for leakage. It's 2, 4, and 6 if I remember. 2, 4, and 6. We already checked 2. Okay, I believe we're good here. Yeah, it's a really strong tube. So let me set that aside and let me recheck just for grins here. Let me recheck this one that came out of the radio. Nothing, 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 nothing. 2, 4, and 6. Let's check leakage. 2, 4, 6. Nothing. I think what I have is an open filament. Okay, that might have been part of the problem. We shall see. Okay, so what I have now, I always put on my tubes, on the tubes that I've taken out of my stash. You see, this is a brand spanking new Lochtel tube, right out of the box. This is a Zenith tube, even. Hey, how cool is that? If he winds up having the work done, he's going to get a new old stock Zenith tube put in his radio. That is cool. So what I do when I pull a tube out of my stock is I go ahead and I put a red X on top of it. That indicates, and I won't put it, actually I'm going to put it on the side of this one because you can't really wipe this off. I'll take the numbers off. These Lochtel tubes, by the way, these numbers, the tube numbers will come off with water and lacquer thinner, so you don't want to mess with either of those. So in fact, I'll put it on the metal base here. Okay, that's the tube that I replaced. That's my tube, the one that's red. Red X indicates my tube again. Brand new, beautiful new old stock Zenith tube. Tested very strong. There's one more tube I need to test. This one that came out of the radio is an RCA. It's a 1A7. Looks like a TV high voltage tube, only smaller. Okay, 1A7, there it is. It's an oscillator tube. Oh, I see. Cool. Okay, this is the converter tube. This is got the mixer and the oscillator ports. So I'm going to do the mixer part first. This very well could be a tube that was causing problems too, because I heard nothing coming through. Nothing. Leakage is 3, 4, 5, and 6. So let's do 3, and we'll put the tube in. This is an octal tube, and it has a grid cap. So let's put the grid cap on. Okay, that's all set. All right, so let's let the tube warm up for a minute. So for the oscillator, or I'm sorry, for the mixer, all right, I'm going to do 3, 4, 5, and 6. 3, 4, 5, and 6. Nothing there. I believe the merit to test the, oh, I keep losing it here. It's going to be 3. Good tube, good tube, good tube. Very strong. Okay, so we're good there. Now, we have done the mixer. Let's go ahead and do the oscillator portion. And now it was good as a mixer. We're checking the oscillator now. Yeah, not quite as strong as the mixer, but pretty strong still. Well into the green. So I think we're good. I think this converter tube is good too. Okay. So we have one tube that was potentially bad when we were checking the radio. It did show good for a second here, but only for a second. Then it died like that. I didn't bump it and nothing. It just, I was pulling the lever and it went up to the good and dropped right back down. And what's really funny is when I was testing this radio, I could swear I saw a filament glow that was just momentary on a tube at the other end of the radio from the rectifier. And that makes sense. That's where this tube would be. It glowed for a second and then petered out right away. So I'm thinking that this tube had a filament that's funky somehow. Maybe it was getting ready to go open, or it was open, but it was occasionally touching. Who knows? But it's definitely open now, and the tube is bad. So I do need to write bad on that tube. And I'll do that in red on the base, just like I put the red X on mine. So I went ahead and put that 1A7 back in. And this original tube that was his is a National Union electric tube. I'm going to put bad. Open filament. Great. So we've done all the testing. Tube tester is off. Now I'm going to go ahead and set the camera aside and get the radio set up to try one more time. All right, we're going to do a quick and dirty here. Let's go ahead and turn on the isolation transformer in the variac. You're going to hear a little background noise, guys. Sorry about that. Okay, radio is on. All right, let's move up the variac. I'll count the voltage off as we go. Let's see, make sure I got everything in place. Speaker's connected. Speaker is connected. Rectifier's in. Power output tube is in. All the others are in. There's the new, right there is the new tube. I'm not sure. I think that's an IF tube. All right, let's go. We're at 100 volts, 110 volts, 117 volts. Let's see what we come up with here. Rectifier is glowing. Nothing. All right, so I am going to try a couple things. My signal generator I never turned off, so it's well warmed up. What I'm going to try real quick, I'm going to try putting a signal to the grid of that converter tube. Okay, I just figured something out here. I don't know how much it's going to help me, but they have a 1A7 in here for the converter tube. And what it originally came with is a 1LA6. Well, someone, looking closer at it, someone has replaced the tube socket because the 1LA6 is a Loctile tube. All right, the 1A7 checks out as a good substitution, an octal substitution for the Loctile 1LA6. So this is a legitimate substitution that's been done with this radio. You know, I haven't checked the coils on this yet. The transformer, the IF transformers, the oscillator coil, the antenna coil. I haven't checked any of that. Probably this weekend, I'll just leave this as is. This weekend, I'll start at the output stage and work backward and see where I lose the signal. So That's where it's at for now. I thought I could get this done quick. As it turns out, I'm not going to be able to. This is probably going to be a two-part bench test video. So I'll go ahead and finish this up this weekend, but I want to post the video for the owner of this radio to be able to see it. All right, guys. And that's all I'm going to do on this one tonight. I'll pick up the radio in the next video. That's all for now.